Hey, Math Be Real here. Before we get on to a 50th derivative problem and an average value problem, I did want to talk to you about where is your foundation of your life. This is really crucial because things are going to come at you, circumstances, problems, issues, things that are your fault, things that are not your fault, and how are you going to handle all that? That's why keeping a planner is so important. That's why having goals, keeping yourself accountable is so important, because otherwise we're just swaying this way and that way, and we feel like our lives is just a myriad of events that we can't control, all right? So with that said, let's get to some calculus.
As always, go ahead and stop this video so you can do these problems on your own. This talks about the average value. We need to know whether we have the average value of a position function, which is simply just taking the slope from the start point to the end point. They usually give us the fact that it's a position function. If it doesn't give us the fact that it's a position function like this question, it is a rate function. In that case, we do 1 over b minus a, the integral from a to b of x dx. So we're going to go ahead and do the integral of 1 over pi over 2 minus 0 from 0 to pi over 2 of cosine of x dx. Now when I go ahead and take the antiderivative, I'm going to go ahead and get the sine of x. Now I am going to go ahead and do 1 over pi over 2, which I'm eventually going to go ahead and just simplify that to be 2 over pi. I'm going to evaluate from the sine of pi over 2 minus the sine of 0. Now let's go ahead and get our unit circle knowledge out. I get the sine of pi over 2, which is the sine at 90 degrees. The y value is just 1. So I'm going to get 2 over pi times 1 minus the sine of 0 is 0. So my answer is E, 2 over pi. For number 8, we're talking about the 50th derivative. Obviously, we're not going to take all 50 derivatives, so we're going to try to find a pattern. So our function is cosine of x. Our first derivative is sine of x. And as we keep going, we're going to notice that once I hit the fourth derivative, I'm going to end up at my original function. So what that means is every fourth time I take the derivative, I get the original function. So what I need to do is go ahead and divide 50 divided by 4. And I end up getting 12 with 2 left over. So I'm going to just forget about those 12 because that puts me right back at the original. And I'm going to go with the second derivative. So that gives me a negative cosine of x.